Assalamu alaikum. This is Dr. Usman Paracha, and we are now having lecture number 10 of the subject Applied Quantitative Analysis and Practices. Now in the previous lecture, let's have a recap of what we did previously, and we went through the various methods of having the box plotting and how to calculate the various indicators used in box plotting, like smallest value, then interquartile range, then first quartile, third quartile, and how these quartiles, when they are calculated, how they are plotted. So normally we had discussed that such kind of plots are made horizontally, but when the same thing is applied in SPSS, then the same concept is drawn vertically. So basically we just went through how through various options we can display the box plotting, and again in SPSS there are various different ways. Whether you can go through it through chart builder option available in SPSS, or you can go to the analyze option and go to the descriptive statistics part, and from there you can explore the data, and your box plotting option is there also. So but again, as we discussed before, that in box plotting, in one option you can customize your box plot application according to your own requirements. However, as compared to that, in other option like descriptive analysis exploring part, you will not be given the option of customizing the box plotting as you intend to do it. So the plotting would be generated automatically through default options in SPSS. So we just went through that, and then we went through various examples of how box plotting would look like of various data, and how to track the outliers or extraordinarily abnormal variables there. Likewise, then afterwards we went through the various population descriptive measures. There isn't much of a difference between population and sample descriptive measures, with the exception of the notations, and with the exception of that, the formulas are round about the same. So we just went through that, and it includes all the measures regarding standard deviation, variation, then range, and all the other measures of variation we discussed before. Then following that, we went through the empirical rule, which is very important, because as empirical rule states that the 68% of data set will lie in between two standard deviations of the data set around the mean. So we already discussed about the standard deviation part and how the mean is plotted in the center, and if we take the two standard deviation distance at the positive side and at the negative side, then keeping in view that range, within that range, as per empirical rule, 68% of data will be there if the data is normally distributed. Coming to this important part regarding the rest of the empirical rule, it also stated that 95% of the data will lie in between two standard deviation of that central mean, and again as we said before, that 68% of the data set, I stand corrected, would lie in between one standard deviation of that central mean in this case. So following that, again, another extension of the empirical rule was that 99.7% data will lie in between 3 standard deviation area within the central mean in this case. So this empirical rule is generally followed for all kind of data sets which are having normal distribution. Now, following empirical rule, we also studied the Chebyshev rule, which basically had an alteration regarding a certain formula including a certain term called k, and we had to calculate it, and based on that we calculated the percentage of data which would lie in between 1 standard deviation of the data set or 2 standard deviation of this data set. Now, the important part regarding the next feature was the scatter plotting. And scatter plotting, basically, as we discussed before, involved the investigation of the relationship between 2 variables. So in order to follow up the investigation of 2 variables, we basically plotted each variable on each axis, one in horizontal axis and the other in vertical axis, and then we plotted the readings on the graph, and then we tried to find out the scatter plot, the difference or relationship in between these relationship by trying to see how much these 2 variables are overlapping with each other. We would have a brief overview of this feature, and then we just had a look at the application of this scatter plot in SPSS. So we would just continue with the same thing because we hadn't finished with the concept previously. So going to the concept, we discussed that scatter plotting, as we have discussed, is the relationship of 2 numerical variables, and basically the quantitative measures of such relationship are termed as covariance and coefficient of correlation. But before going to that, let's have a detailed look of how and what kind of scatter plotting can be done in SPSS. So just have a look at the example in which we basically took a data set in which some students were examined and their anxiety level was measured through questionnaire, and relevant scores were obtained. As you can see that these values are entered in 4th column here, and likewise against that we calculated their examination score, which is displayed in the 3rd column, and also we calculated the time they took in revising the material for examination. And basically what we want to know is the relationship between anxiety and exam performance, and also how come the time taken for revision affects these other 2 variables. So before going ahead with the complex software application and complex statistical analysis, we always try to have an overview of relationship between variables through scatter plotting. And in order to do that, what we do is we just click on graph and click on chart builder. So let's say we first go for simple scatter plotting, and as we discussed before, we just try to plot the exam anxiety with the exam performance of the students. And again as you can see, you can get any number of values. We can examine any number of values in this case, and we can also mention here, as it is displayed here in the drop down menu, that we can get their mean calculated on x-axis and median calculated, and any kind of measure we want in the x or y-axis. But here we are more concerned with their original values. Then again, let's click on OK, and as we discussed before, that there seems to be an inverse relationship between exam anxiety and exam performance, and this is evident from the fact that the people who were having high exam anxiety scored low in exam, and those students who had low exam anxiety scored very high in their exams. And we also discussed that if we double click on this graph, we will see the editing version of this graph, and in order to have a pattern line drawn, or also called a regression line, in order to have a brief look at the nature of relationship between these two variables, all what we have to do is click on this button, which is displaying add fit line at total, and by clicking on this line we can see that we are being asked about the fit method which should be used. Here we are more interested in the linear relationship, so we just click on that. Then we can see that there is a line being displayed here which gives us a brief overview of the nature of relationship between these two variables. Once we have gone through that, now we can look at the other ways through which the same information can be displayed by clicking on cross. Now from here it is very much evident that there is not much of a noticeable outlier here. Going through the graph and the chart builder option again, we have got other options as well, like besides the simple scatter plot, there is another option which is being showed on the mouse here, and by dragging this option in the central preview, we can see that different colors have emerged, and in this case you see this kind of scatter plotting is also called grouped scatter plotting, and here we can differentiate between different types or the different genders or any type of nominal variable involved, and we can see if the relationship differs in between those nominal variables. Here in this case we have got two types of gender, male and female, and if we want to know the relationship of these two variables in males and females separately, then we can make use of grouped scatter plotting, and we can do this by first dragging this group scatter option in the central window, and we can see that the rest of the option remains the same, but here in the upper right corner there is another option now being displayed which states set color. So in order to do that, we just have to mention the variable which will be used to differentiate between the values of male and female, and here the gender is option is for you. We drag it to the set color option and we put it here. Now you can see that the gender option is now being enclosed in set color box, which is shown here. So we just click on OK, and we can see that the same graph is being displayed but showing different colors. Now here one color represents the male, which is blue, and kind of greenish color is of female. So here, if we want to have a more clear picture of the relationship or the difference of relationship between these two genders, then we can just double click on the chart here, and again we can see that the editing version of the chart editor is opened here. Here, if we click on the button shown on the mouse, which is next to the add fit line, and it displays add fit line at subgroups, so we just click on this one. So again it is asking for whether we are looking for a linear relationship or quadratic or cubic and other relationship. So here we are only interested in linear relationship. So we just basically click on that and click close. And now once we have gone through that, we can see that two basically display lines are here, and which basically represent the nature of relationship here. And in this case you can see that in male this relationship, the inverse relationship, is stronger as compared to the female relationship, which is displayed by the regression line. So this is one very effective way of comparing the intensity of relationship of any two kind of variables if we are comparing them between two nominal categories. So this is very much effective option to do that. Then coming to another option in the graphs submenu, we go to the chart builder again, and here we can see a three-dimensional diagram is being shown here. Now in this case, if we are interested in having a look at the 3D scatter plotting, in here in which we have the option of a third variable impact on these, so we just drag it, and here you can see that the x-axis and y-axis readings remain the same, but SPSS is asking for the third intervening variable, which we may want to have a look on, so that we can know what's its impact on the rest of the relationship. So the third variable, as we can see, which we discussed about, was the time spent by the students in revising the material for the examination. So let's drag it to x-axis and put it there, and we can just click on OK. So here you can see we have got basically a cube, which basically represents a complexity of relationship between these three variables. But this kind of graphical representation of scatter plot makes it a bit confusing, because it's not easy to assess the nature of relationship between these. Again, if you want to basically have a look at have a more clear look at the nature of the cube, we can also rotate it for more clarification purpose, and by clicking on this specific rotational option, let's see if we can have a look at it. By double clicking on this again scatter plot, we will go to the editing option, and in editing option you can see in the first menu bar below the main menu bar there's a button on which the mouse is being placed, which is representing rotating 3D chart. So if we click on this, we are now being shown options of vertical and horizontal. Now these dimensions can be maneuvered to tilt the diagram in our required direction. So let's say if we just gave the vertical option as 30, so you can see that the cube or the 3D diagram of this relationship is now rotated. So similarly, this three-dimensional shape can be further rotated, let's say to 69. Again, you can see another different way of having a look, but it's up to you that to how much extent you want to get it rotated. If you want to put it back to its original form, we can click on reset button and it can come back to its original form. But however, this must be kept in mind that normally including a third variable in scatter plotting, specifically while using the three-dimensional grouping scatter plot, normally it does confuses the interpretation of these dots being presented. So that's why it's not that much advisable to go through that. However, the exceptions are always there if it is required. So going to the graph option again in chart builder option, we have got some additional options as well. Like if we have a look at this 3D grouped scatter, again we have got another option of grouped 3D scatter, in which we can also differentiate between the nominal variables, just like as we did in grouped scatter plotting, in which we just tried to see the relationship between two variables, and we tried to compare the two relationships between male and female. So the same application can be gone through in this three-dimensional grouped scatter plotting as well. So dragging it to the center, again now it is showing the same three variables which we placed in the relevant axis, and we are now being again asked for the set color option, in which basically SPSS is asking for the main variable which will be used to differentiate basically between the relationships of the three variables displayed here. So let's drag the gender option to set color option here, and while placing it here and clicking on OK, you would just see that here basically the same diagram is being displayed, and in this case you can very well see that the relationship of the three variables can be differentiated based on male and female. But here again, as it has been evident that the relationship would not be that much clear, as the three variables normally get this pattern confused, though it is obvious that the three kind of variables are somewhat interlinked to each other, and they may have some importance in this case. So we would have to look at it more deeper to understand the relationship between these variables. Going to the graphs option again and clicking on chart builder, let's explore the other options. Here just below the main 3D group scatter option, we can see a scatter plot matrix, and here just dragging it to the central area, we can now see a kind of a matrix diagram which is being showed in the central window, and we have to find out the relationship between all the three variables, which we did try to find out in the 3D pattern, but as we discussed before, that from the 3D pattern this relationship between these three variables was not very much clear, and it was a bit confusing. So this matrix basically methodology helps us try to understand the relationship between these three variables more effectively as compared to the 3D part. So by clicking and selecting all the three variables, which can be done by first clicking the first variable, and by clicking on shift button and clicking on the last variable, we can see that all the three variables have now been selected, and we can just drag these three variables to the x-axis, which is the only axis being displayed here, and by dropping it here we can see that some different kinds of patterns have emerged, but in order to have a detailed view, let's click on OK, and here we can see a group of scatter plots have been formed in which the scatter plot between every two different variables is being displayed. And here you can see, for example, that the relationship between revision and anxiety is being shown in this box, and it shows an inverse relationship. Likewise, in the relationship between exam and anxiety, it is very clear that an inverse relationship exists. Similarly, in the relationship between revision time set for examination and the examination score, there's kind of a direct relationship. So the diagonal is empty because it doesn't make any sense to find out the scatter plotting between two similar variables, and the variables or the scatter plots which are being shown above the diagonal are exact copy or replica of the relationship which are below the diagonal. So our concern here is to find out the pattern of the relationship between these three different variables. Now from here, this is clear that the nature of relationship in between these three variables is quite different, and in order to have a more clear picture, let's add the fit line, and by double clicking on this matrix option we can again apply the same technique which we have used before, and by clicking on the button which is displaying add fit line at total, by clicking on it, again we have to choose between the linear, quadratic or cubic or other option. So we are interested in the linear option here, so we just click on close, and you can see the relationship diagrams or the basically regressed lines are now being displayed here. So these regression lines basically gives us a more clear picture of the relationship between these different variables, and in this case the scatter plot matrix is very much effective in giving us a complete picture of more than two variables involved. However, it is advisable to not go beyond three variables in scatter plot matrix, because sometimes this can become more confusing if more variables are involved in this case. So going back to the graphs here again, and going to chart builder option. Now let's go to another scatter plotting, which is besides the simple dot plot, and by just putting it here, it's similar. This option is very much similar to the histogram. The only difference is that here these values are being shown in the form of dots instead of bars. So just dragging the first variable exam anxiety here, you can see the simple dot plot here, and by clicking on OK, we can see that here the dot plot of the basically variable exam anxiety is being showed here in SPSS. So coming to this, basically we have got numerous tools here which exist in SPSS to assess basically different kind of scatter plotting and to assess the nature of relationship between any types of variables. And scatter plot is basically very much effective in giving us a very initial idea of how a certain relationship would look like before going into details. However, not much details can be got from the scatter plot, because it just gives us an overview. So coming to the more main descriptive analysis part, now the scatter plot's further stage is basically refined in the form of two basic measures called the covariance and coefficient of correlation. Now coming to covariance part, it's again the measurement of the strength of linear relationship between two variables, and the formula basically is very much evident here, in which basically what we are trying to do is to find out the average distance of the individual values from their respective means of both the variables, and then multiplying them with each other, and we just take a summation of that. We divide it with sample size n minus 1. So here in covariance formula, it is very much evident that it would just gives us a very vague figure of the intensity of relationship between the two variables. However, from this covariance part, we cannot deduce whether which variable is causing the other. So this is one disadvantage of covariance. Second disadvantage is that covariance would gives us the number or report in the same unit in which the two other variables were, because of which the covariance figure cannot be compared with other covariance figures of some other entities. So that's why here basically the main interpretation of covariance between any two variables is that if covariance is greater than 0, then both variables are in the same direction. They have the relationship in the same direction, and change in one variable in one direction would cause the change in other variable in the similar direction. Then if the covariance is less than 0, then that means that there's a kind of an inverse relationship between the two variables, and in this case then if one variable increases, then the other variable would decrease or move to opposite direction. However, if the covariance is 0, then that means that both variables are independent of each other. Then the flaw is being stated here, which we have discussed before, that basically the strength of the relationship cannot be found out through covariance. Now, in order to find out the covariance, we can go to SPSS. So here basically covariation is not of a much presence here, and here we can see that instead of covariation we are only have been given the option of calculating the variance basically in between two variables, which is evident from the compute variable option in a transform, and we can see in the drop down menu in functions and special variables the variance option is enlisted, but covariation basically is not present in SPSS. So going back to the detail here, basically the covariance is not that much reported between the two basically variation between the two variables. Reason because of the same flaw which we have discussed. Now, countering that covariance, there is another coefficient which is calculated and is also termed as coefficient of correlation. Now, the difference between the covariance and coefficient of correlation is that here we are dividing the covariance of the two variables with their respective standard deviation. Now basically in this way we are standardizing the measure of covariance to basically a scale which ranges from -1 and 1, and it does gives us the coefficient of correlation, whose strength, as we have discussed now, ranges from -1 and 1, and it is standardized, and then because of that coefficient of correlation can be compared with any other correlation figure of any other two variables. So this is its main strength, and that's why the formula here you can see that it's basically the calculation of covariance of the two variables and divided by standard deviation of the respective variables here. Then following this, the important features are that the population coefficient of correlation is represented by rho, and the sample coefficient is being represented by small r. Again, there are certain features like they are unitary, and as we discussed before, that the values range from -1 and 1. And again, the stronger is the relationship basically when the values are approaching 1, and similarly if the values are approaching -1, then the negative relationship strength starts increasing. So basically by having a range between -1 and 1 gives us a fair advantage of analyzing the data more effectively. And similarly, if having the coefficient of correlation equal to 0 would be in fact telling us that there is no relationship between the two variables. So this feature of standardization in coefficient of correlation gives us a very good advantage over covariance figure. So in order to find out the coefficient of correlation, we can go to SPSS here, going to the same example of revise exam and anxiety. Let's click on analyze and click on the option called correlate, and here the first option is bivariate. We are interested in trying to get the relationship between two main variables, so we click on bivariate here. So now here we can see that there is a variable list required on the right hand side of the dialog box, which is opened here, and the relationship which we want to find out here, the variables regarding that can be selected, like as the exam performance, and by clicking on arrow it is now included in variable list. Likewise, we can click on exam anxiety and we click on arrow to include it also here. So now we are having two variables here, and we are being displayed various correlation coefficient here. The first one is Pearson, then the next one is Kendall-Stowe, and the third one is Spearman. Now each correlation coefficient has got its own functions. Pearson correlation coefficient is generally found out when both the variables of whom the relationship is being tried to find out have got the basically interval or ratio scale. In other words, in SPSS, simply scale measure. So if both the variables are having basically interval or ratio scale, then Pearson correlation coefficient is very much ideal to find out the coefficient of correlation in this case. Then in case of Spearman and Kendall-Stowe, the specifications of the data need to be different. For example, in Spearman, if we want to find out the relationship between variables in which at least one of the variable is having an ordinal scale, then in that case we use Spearman correlation coefficient to find out the strength of the correlation in between the two variables. The test of significance, whether it's two-tailed or one-tailed, this we will discuss later when we are discussing the normal distribution, which would come later now. Then coming to the options part, here it is mentioned that statistics, whether you want to report the means and standard deviation in the result, or you want to display the cross product deviations and covariances. It's up to you whether you want to get the statistics displayed or not. Then under missing value, we have to state whether if the values of any case are missing, then what should SPSS do to deal with such kind of missing data. So excluding cases pairwise or excluding cases listwise is one of the many options which are present here. So by clicking on continue, now we can click on OK, and here you can see table is now being displayed, which is displaying correlation between exam performance and exam anxiety. Here you can see that exam performance relationship with exam anxiety is shown in the third column in the second row, and here it is termed to be minus 0.441. Now here this must be taken into account that correlation coefficient whose value is less than 5 is considered to have weaker relationship in between the two variables. So the value above 5 is above 0.5 is considered fair enough to have shown some kind of relationship between the two variables. Now here, as you can see, that the value of correlation shown in between exam performance and exam anxiety is turned to be less than 0.5. So it's kind of a weak relationship between these two. However, the significance here, which is termed to be two-tailed, is less than 0.05. So the results are significant. Now the value and why we are terming this correlation thing as significant, we will discuss this in detail in coming lectures. Now here you can see the value of n being shown in the third row in the second row in this case, and n is termed to be 103, which is basically telling us about number of valid cases of whom the correlation coefficient has been calculated. Similarly, in the third row here, the same result has been repeated in under exam anxiety and in the second column. It's just it's just the way in which the results of the correlation coefficients are displayed. So there is nothing to worry about this presentation. So this is how we calculate the correlation coefficient of any two variables. However, more than two variables correlation coefficients can be calculated by clicking on Analyze and going to Correlate, and by clicking on Bivariate. Now if we want to have a look at the impact of the third variable, which is like the time spent revising in exams, so we just click on it and we select this one, and by clicking on OK, now we can see that now in the tables the third variable is now being represented, and the third variable's performance the correlation of the third variable with all the rest of the two variables is being shown here in the as you can see in the arrow. But it is evident from here that the correlation between exam performance and time spent revising is 0.397. Again, it's less than 0.5. So it's kind of a weak relationship. However, the relationship between exam anxiety and time spent revising is 0.709, which is quite high, and it shows a strong correlation or strong relationship between the exam anxiety and time spent revising here. So basically in this way we can include any number of variables to find out the strength of the relationship between them. And again, this must be kept in mind that the relationship between all these variables is quantitatively shown through relationship. However, it does not give us any detail about the causal effect of any kind of variable involved here. So that's also one of the discrepancy of correlation here. Now basically This is the way how we represent and calculate the correlation. We will discuss in detail about the other option, which, as you can see in the correlate bivariate option, we have got two other coefficients like Kendall's tau and Spearman. So how to go ahead with that, we will discuss it in the coming lectures. So let's come back to the main topic again. So in this lecture, basically we discussed about the various scatter plotting methods in SPSS, and likewise we also discussed about the covariance and what are the discrepancies of covariance, and the reason because of the discrepancies of covariance, we introduced the coefficient of correlation, which was most probably the standardized form of covariance in this case, and which made it more easier for us to assess the intensity of relationship between two variables. In this case, again, we discussed the scatter plotting, different application in SPSS, how we can overview the data more effectively if even the third variable is involved, and likewise in covariance and also in specifically coefficient of correlation, how we can calculate in SPSS. In SPSS, though, the facility of covariance is not there, but we can calculate the coefficient of correlation very much easily in SPSS, and this also gives us additional detail about the intensity of relationship, and also it has got some additional facilities which would be done in next lectures. Now its application was done in this lecture in a specific example regarding students who were experiencing anxiety in exam, and their exam performance was measured, and then based on the time spent in revising the material for the exam, we were trying to assess the relationship between these various options through the coefficient of correlation and also through scatter plotting. So when we have discussed this coefficient of correlation also and related phenomena like scatter plotting and covariance, this is worth mentioning that there is another phenomena which we will discuss in future, and it is termed as regression. And regression basically is adding another important feature in coefficient of correlation. The difference between regression and coefficient of correlation is that in correlation we cannot give any causality and any description of causality between any two variables. We can say that the two variables are related to each other, but to say that one which variable causes the other one is one thing which coefficient of correlation is unable to explain. So in this case we will be doing the regression analysis, which is again a more sophisticated analysis, and that analysis takes into account and also gives us the sense of direction and tells us which variable causes another, or which variable is predicting the other variable in this case. So again the direction aspect gives this whole debate of a relationship finding a new dimension, and that's why coefficient of correlation is reported in every analysis which we basically perform. If we want to find out relationship between two variables or more than two variables, coefficient of correlation among all the variables will always be standardly reported, And the importance of that still remains the same, because in regression analysis, when even sometimes sophisticated techniques are unable to give us some vital information due to the I would say due to the complication of having too many variables and too many interrelationships in between them, then we have to rely solely on coefficient of correlation. That's why it is pertinent to say that ignoring the importance of coefficient of correlation just because of the fact that it is too simple and it is reporting simply the relationship and not much details is not wise. And that's why this coefficient is reported in every sophisticated relationship technique, which we will also do in future lectures also. So that's why despite having the episode of a regression, which is a bit more advanced technique, this coefficient of correlation importance still remains there. And the regression aspect, which we will discover later, though it does give us the regression, this direction issue, but in case when we are dealing with too many independent variables, impact on dependent variable, then in that case coefficient of correlation report is also vital, and it gives us very additional information which maybe a regression analysis may even not give us. So I hope that you clearly understand this lecture. Thank you so much. Allah Hafiz.